we're on to chapter 5 and a start of our stuff talking about angles and trigonometry. And so we have in terms of our actual coordinate system and in terms of the quadrants, goes 1, 2, 3, and then this is quadrant 4. I work this around in terms of angles. You got this would be 0 degrees. This is 90, 180, 180, again, 180 degrees, 270, and then all the way around is 360 degrees. Going in this way is considered to be in the positive direction. And then if you go the opposite way around, this is the negative direction. So we can measure angles in terms of degrees. We can also measure angles in terms of radians. And so if we do this again, and we have our chart. So we said this is 0, 90, 180, 270, and then this was 360 degrees. Now, 0 degrees is also 0 radians. 180 degrees is taken to be pi radian. So if 0 degrees is 0 radians, 180 degrees is pi radians, then 90 degrees ends up being pi over 2 radians. Right? Well, again, if 0 is 0, 180 is pi, then 360, which is twice 180, well, this will just be 2 pi. And then 270, which is halfway in between these two, ends up being 3 pi over 2. So we have in terms of the quadrant angles measured out in radians and in degrees. So if I want to convert from one to the other, right? So in terms of conversion, we're going to use as our conversion factor that 180 degrees is equal to pi radians. Right? So let's say I want to convert 30 degrees. And I want to know what is that going to be in terms of radians. Well, we have our conversion factor that 180 is equal to pi. And so we have in terms of this proportion, and so we can solve this for x. And so we get that 30 pi over 180 is going to equal x. And then the next thing we do here is we simplify the fractional part, and 30 over 180 is going to leave us with pi over 6. And so we get pi over 6 radians will be our answer for this. Okay. Another example. So let's say we want to convert 315 degrees. Okay. Radians. So 315 over 180 is going to equal x over pi. Again, solve for x, so we get 315 pi over 180 is equal to x. And then we want to simplify this fractional part. And so when you do this, you will end up with 7 pi over 4. It ends up that 45 goes into both 315 and 180. So we get 7 pi over 4 radians. Well, then you should be able to convert from radians into degrees. So now we want to convert 3 pi over 5 in 2 degrees. So we want to go this in the other way. So we have 3 pi over 5 is going to be x. We know that pi radians is 180 degrees. So we have our proportion. Now this compound fraction actually simplifies quite nicely. So this ends up just becoming 3 over 5 equals x over 180. And so then it's a matter of solving that for x. And so we get 3 times 180 divided by 5 is equal to x. And so x in this case is 108 degrees. Now, like I said, that 3 pi over 5 over pi simplifies to just 3/5. And just how that works, after all, this means 3 pi over 5 divided by pi. And again, the way you divide fractions, you leave the first one the way it was, change the sign of multiplication, and flip the second one over. So this would be the same thing as pi over 1. And so this becomes 1 over pi. And then when I do that, the pi's will go away. And we do indeed end up with just 3/5. Right? So you should be able to get it convert back and forth between radians and degrees. Now, other thing about angles, and you get angles that are called what are called to be coterminal. And so, for example, if I had an angle of 30 degrees, right, we can also say, well, if I did this angle, and I went around this way, I'd also end up the same spot. And so you have that angle, right, would be negative 330 degrees. Right? So we also end up there. Right? And so if I start out with 30 degrees and I say, okay, what angles can I use and get to the same spot? Well, I go 30 is here. But if I go around again, and I do 390, I'm also in the same spot. If I go around the circle again, 750, I'm in the same spot. Right? And then I get the same thing going in the negative area. So if I did negative 330, I'm in the same place. Negative 690, and so on. They all end up, you're at the same spot, okay? I can also do the same thing if we were talking in terms of radians. Okay. So again, if I have here, and this is now pi over 6, and now I know what's coterminal with that. Okay. Oh, again, if I go around this way, and so that angle, after all the way around the circle is 2 pi. So this is going to be 2 pi minus pi over 6. And the way to subtract fractions is to have a common denominator, which in this case will be 6. So I can rewrite this as 12 pi over 6 minus the pi over 6. And so we get, this will be a negative 11 pi over 6. Right? And then I could get the other possibilities by adding 12 pi over 6. Okay? So we'll get pi over 6. We would also then have 13 pi over 6, 25 pi over 6, And then I could go the same in the opposite direction. And so negative 23 pi over 6 and negative 35 pi over 6. Right? So coterminal angles just end up at the same spot. Now, so in terms of equations dealing with circles and this stuff, so we have in terms of circumference of a circle, C equals 2 pi r. You've probably seen that before. Really, circumference is a measurement around the outside of a circle. And so if you go all the way around the circle, you're going 360 degrees, which is 2 pi. Right? So you have in terms of the formula for arc length. And circumference is just a special arc length. It's the arc when you go all the way around a circle. And so if I have in terms of a circle, has a radius of r, right? Some angle, whatever that may be, theta. And then we have that this would be the arc length right there. And what is the name for that is s. And so s is equal to r times theta. And the angle here has to be in radians. Just like it is in here in my circumference formula. Right? So then, for example, if r is equal to 5 feet and theta is 3 pi over 5, I want to know what is the arc length. So it's a matter of just taking our numbers and plugging them into our formula. So s is going to be 5 times 3 pi over 5. Well, and anytime that the 5s will cancel each other out, and we'll end up with just 3 pi. The units will be the same units as our radius, so feet, or 3 pi is roughly the same as 9.42 feet. Right? Be the arc length. So we got in terms of arc length formula. We can also find out in terms of area of a circle. And so we have in terms, again, our circle. We have in terms of our r value. We have in terms of our theta. And now we want to find out what is the area of that wedge. And so the area is given by 1/2 theta r squared. Okay. So let's do another question. So we want to go, so here we know that if r is equal to 6 meters, and theta is 72 degrees. I'm going to find out two things. Find the arc length. So find the arc length. And then the area of that sector. We're going to find two pieces of information in regards to this, right? Well, again, first off, we must have our angle in terms of radians to use these formulas. So the first thing you got to do is I need to convert 72 degrees into a corresponding radian measure. And so we got 72 over 180 equals x over pi, and solve that for x, and we get 72 pi over 180. In this case, I'm not going to bother simplifying this because I really don't want that as an answer to the problem, so I never worry about simplifying that fraction, because I can just plug it in the way it is there into our next step. And so first off, the arc length, which is r times theta. Okay? So S equals r times theta. So this is going to be 6 times 72 pi over 180. And you plug that in, you end up with 7.54 meters. Right? So that's the arc length. And then we want to find out the area. And so we said the area is given by 1/2 r squared theta. Same way I had it before. 1/2 theta r squared. And so the area, 1/2 is the same as 0.5, which might be easier to plug in on the calculator. Angle was 72 pi, 180 times 6 squared. And if you plug that in, you find out that the area of that piece would be 22.62 meters, and that would be squared. Right? So we know in terms of the arc length and the area of that piece. Other things dealing with circles, we have in terms of angular velocity. Okay. And so if you had a circular plate, and I said it had 3 points on the plate, on that plate, so let's say here, here, and then here. So this is point A, this is point B, and this is point C. Okay? And I said, well, which one is turning faster, the having faster velocity? Well, A looks like it really is in the center of the circle, and so basically that would basically have the lowest angular velocity, have none, and then C would have the highest angular velocity because it is at the edge. Okay? So angular velocity, and the symbol for that is given by theta, the angle, divided by the time, t. And then linear velocity is given by the arc length divided by time. And we also have that from what we had earlier. We know that S is equal to r times theta. Right? And so I could also rewrite that the velocity would be r theta over t, right? But we know theta over t is angular velocity, and so velocity is given by r times. Right? So we have in terms of our formulas dealing with this, and so we'll look at how this works in terms of some questions. So we get something like this. Determine the linear velocity given r is 3 feet. And the angular velocity is 4 radians per second. Okay. So we have that the velocity is given by r times omega. So this is just going to be 3 times 4, and we end up with 12 feet per second. Right. Okay. So we get 12 feet per second, but then we go, well, let's say I want to know what is this in terms of RPMs, revolutions per minute. So I want to convert our feet per second into RPMs, revolutions per minute, right? So let's go through that conversion, right? So we got 12 feet per second, right? We know that there are 60 seconds in a minute. And we know that one revolution is given by the circumference of our circle. And so one revolution is given by 2 pi r. And so we plug that all in, we end up that this would be the same thing as 38.2 RPM. So 38.2 revolutions per minute. So then we get in terms of right triangles and right triangle trigonometry. So we have in terms of our right triangle. Like that. Okay. And so we'll call this A. This would be B, and then this would be C. Side A is opposite angle A. Side B, opposite angle B. And side C, opposite angle C. So the vertexes are in terms of the capital letters, the sides are in terms of the lowercase letters. Right? So we get in terms of our trig functions. Right? And so we have in terms of the sine of A is given by opposite over hypotenuse. So this is opposite A, so this is A. The hypotenuse is always the longest side of a right triangle. Right? You get cosine, which is adjacent over hypotenuse. So this angle, this side is adjacent to A. So this is going to be B over C. And then you get tangent, which is opposite over adjacent, which is going to be A over B. And those are the 3 main trig functions, okay? Those are the ones you have buttons for on your calculator. But then along with those 3, there are another 3. And so you get the reciprocals of these, and so you get cosecant, which is hypotenuse over opposite, which will be C over A. You get secant, which is hypotenuse over adjacent, which is going to be C over B. And then lastly, you get cotangent, which will be adjacent over opposite, which is going to be B over A. And those are the 6 trig functions. So then, for example, given a right triangle, you should be able to write out all the fractions that we had. So if I had this right triangle, here's my right angle. We'll say this is my angle theta I'm interested in. And this is 3, this is 4, this is 5. And I want to write out the 6 trig functions. So we got sine theta is opposite over hypotenuse, so that's going to be 3 over 5. Cosine is going to be adjacent over hypotenuse, that'll be 4 over 5. And then tangent is opposite over adjacent, which will be 3 over 4. And then if I want to write out the other 3, well, they're just reciprocals of the first 3. So cosecant is going to be 5 over 3. Secant is 5 over 4. And then cotangent is 4 over 3. And so we have all the fractions for all 6 trig functions. So we have in terms of our trig function in terms of a right triangle. We can also rewrite this in terms of what happens on a circle. So if I have a circle, this, and we have here is my R, here is my theta. This point on a circle is given by the coordinates x, y. And then, if I drop a perpendicular down to the x-axis, okay, and I look at this part here, I have a right triangle. From here to here is going to be given by the x-coordinate. From here to here is given by the y-coordinate. And so I can rewrite my trig function now in terms of this. And so we would have that sine theta is going to be given by y over r. Cosine theta is given by x over r. And tan theta is given by y over x. And then if I write out the other three, the reciprocals, we get cosecant is r over y. Secant is r over x. And cotangent is x over y. So I can rewrite this in terms of my circle, in terms of x's and y's and r's. Well, we also know that in order to have a circle, we have to have a radius which is a positive number. And so if I look in terms of my quadrants, 1, 2, 3, 4. We know r has to be positive, okay, in order to have a circle. And I say, okay, what's true about my trig functions as I go around? And so, which trig functions are going to have a positive value in quadrant 1? Well, it ends up that all trig functions are positive in quadrant 1, okay? And then we go to quadrant 2 and want to know which one's positive. Well, in quadrant 2, the x values are negative, but the y values are positive, and so it ends up that sine and cosecant are positive here. Right? In quadrant 3, you have x and y are both negative, and so we have that tangent and cotangent are positive in quadrant 3. And after all, a negative divided by a negative gives you a positive number. And then lastly, in quadrant 4, you have x is positive, but y is negative, and so you get cosine and secant are positive in quadrant 4. So you have in terms of that information. Right? Well, other thing regarding angles, right, you have what are called reference angles. And again, reference angles, just like when we talked about in terms of those various properties of logarithms, product rule, quotient rule, and so on, apparently have sort of lost their usefulness, because if I ask you on your calculator to find the sine of whatever angle, your calculator can do it, right? But again, you used to have tables in the backs of books, and you could now put in there the sine of whatever angle, okay? And so you had reference angles, right? So the reference angle was always in terms of the x-axis. So in the first quadrant, whatever it was, okay? When you got to the second quadrant, oops, not what I wanted, let's do this. So we'll make this here, and now my angle is over here. We're in the second quadrant. So here's my angle theta, okay? And so my reference angle was this part here, which would be 180 minus theta. Okay? I go to the next quadrant, so now I'm down over here. Okay. And now we're in this spot. And so the angle I want in terms of my reference angle is always to the x-axis. And so this is going to be given by theta minus 180. And then lastly, when I'm in the fourth quadrant, and so now my angle is over here. So here's my angle. My reference angle would then be this piece here. And so that will be given by 360 minus theta. So we got reference angles. Okay? We can also look at these also in terms of radians. And so if I do the same formulas in terms of radians, so this would be pi minus theta. This would be theta minus pi. And then this is 2 pi minus theta. Okay? So reference angles. Okay? So in terms of on the calculator, you can do sine, cosine, tangent of whatever angle. So for example, if I say, what is the sine of 30 degrees, okay? You plug that in, you should get 0.5. Okay? Again, make sure when we're doing trig functions, you gotta make sure about the mode of your calculators. One of the few times the mode does matter. And so depending on whether we're talking about angles in degrees or radians, it does make a difference, right? You also notice that on your calculator, you'll probably see where you have the sine, which is on the button, and right above it, you'll see things like sine minus 1, cosine minus 1, tangent minus 1. So then if I say, well, what is the sine inverse of 0.5? So if you did this, sine inverse of 0.5, you should get back 30 degrees, right? And so you got those two are opposite of each other. Right? Oh, what's the other thing you should be able to do? So let's say now I have in terms of a circle. So I have my circle. So something like this. My radius is 10. We know the radius is 10, and this is 120 degrees. Okay. And I want to know what are those x and y coordinates there. Okay. Okay. So I know those x and y coordinates. So we said we had up earlier that sine theta was equal to y over r, and we said that cosine theta was given by x over r. So I could take those two equations and solve for x and y. And so basically all we have to do is multiply by r, and so y is given by r sine theta. X is given by r cosine theta. So now it's just a matter of taking our numbers, and so y is going to be 10 times the sine of 120. X will be 10 times the cosine of 120. And we plug those in. We get that this will come out to be -5. And this will come out to be 8.66. And so my xy coordinate will be -5. And that would be the coordinates of that point on the circle. Okay. So let's use these to answer some questions about a right triangle. So let's say we have a triangle. Let's say this. Okay. So this is 42 degrees. Let's say this is A. Let's say this is B. This is C. That's my right angle. And this is 20, right? And I want to know all the missing pieces. So I want to know what is the measurement of this side, I want to know what is the measurement of the length of this side, and I want to know what that angle is. So let's do B first, angle B first. Well, the sum of the angles in a triangle has to equal one angle. So angle A plus angle B plus angle C has to equal 180 degrees. Right? So I can use that in order to get angle B. Right? But after all, that's a right angle, so we know that's 90. The other thing about a right triangle is that these other two angles have to equal 90 because we know this is 90. Right? So if I solve this for angle B, so we got 42 plus B plus 90 equals 180. So B plus 132 equals 180. Subtract. And we get that angle B is 48 degrees. So we got that piece. Right? Now I want to find my two lengths. Right? Well, so relative to this angle, this is the opposite side. This is the hypotenuse. So I could write out that the sine of 42 is going to equal 20 over C. And then I can solve that for C. So the opposite of dividing is to multiply. So I get C times the sine of 42 is going to equal 20. And then the opposite of multiplying is to divide. So we'll divide by sine 42. And so C is going to equal 20 over the sine of 42. And if we plug that in, we get 29. Right? So now we need to find side B. Right? Well, we got, here's B. We know that this is now 29.9, so we could say that the cosine of 42 is equal to B over 29.9. And the opposite of dividing is to multiply, and so B is going to be 29.9 times the cosine of 42. And we put that in, we get 22.2. So we have all the missing measurements in this right triangle. But one last one, and that is now given something like this. We have that this angle is 25 degrees. We know that this angle is 12 degrees. Right? We'll call this measure from here to here D. Right? And we know from here to here is 300 feet. Right? And we want to know how far are we away from my border there. Well, so we actually have a couple triangles here. So if I say from here to here, right, and then here from here. Well, we know the total distance here is 300. So if I say that this is x, then that means that this piece has to be 300 minus x. Right? And so now I can look in terms of for my D here, and so we got opposite, adjacent. So we got the tangent of 25 is equal to 300 minus x over D. And if I look in terms of the bottom triangle, we get the tangent of 12 is equal to x over d. Okay. So let's take this one and solve this for x. So x is going to equal d times the tangent of 12. Right? And so we can take this and we can substitute it into our other equation. So I'm going to take this, because we know this is x, and so x is x, and so we can substitute into our other equation, and then get something that we can solve. So we get the tangent of 25 is going to equal 300 minus d times the tangent of 12 over d. Well, the opposite of dividing is to multiply. So d times the tangent of 25 equals 300 minus d tangent of 12. We can then plug in the calculator and get a value for my two tangents. And so this will become 0.466d equals 300 minus 0.213d. And now it's a matter of getting the d's on the same side, so we'll add them. So add 0.213d, add 0.213d. So we get 0.679d equals 300. And then lastly, we will divide. And so we end up that d is going to be 442 feet. And with that, that will conclude this lecture.